The journey of microchip production begins with a fundamental element: silicon. This essential material is sourced from purified quartz sand, a raw material that undergoes transformation into large, cylindrical ingots. These ingots are meticulously sliced into thin wafers, typically 300 mm in diameter. The precision of this slicing is crucial. These wafers are polished to a mirror-like finish, creating a pristine canvas for the intricate patterns that will later take form. Once the silicon wafers are prepared, the next phase is photolithography, where artistry meets science. A photosensitive substance known as photoresist is applied to the wafer's surface, ready to receive intricate designs. Ultraviolet light is projected through a mask, which imprints delicate circuit patterns onto the wafer. Thanks to advancements in extreme ultraviolet (EUV) lithography, engineers can create features that are a mere few nanometers wide, pushing the boundaries of what is technologically possible. Following patterning, the wafer undergoes chemical etching to carve out the defined pathways of the microchip's circuitry. This process is akin to sculpting, as unwanted silicon is exquisitely removed, revealing the intricate structures beneath. Thin layers of metals and insulators are then deposited onto the silicon using cutting-edge techniques like chemical vapor deposition, CVD, and atomic layer deposition, ALD. This layering process is essential for forming interconnections that will ensure the chip functions efficiently. As the circuitry takes shape, doping occurs, wherein dopants such as phosphorus or boron are implanted into the silicon. This step modifies the electrical properties of the silicon, creating the ability for transistors to switch and form the functionalities that power modern electronics. The chip then continues to evolve with the addition of more layers, each contributing unique attributes to the final product, interconnected through microscopic copper or tungsten vias that resemble a complex city grid. Quality control is paramount in microchip manufacturing. Every chip is subjected to rigorous electrical testing to confirm its functionality once it has been sliced from the larger wafer. The successful chips are packaged in protective casings, ensuring their safety before integration into devices. Ultimately, these chips are carefully distributed to manufacturers, who then breathe life into everyday gadgets, revolutionizing the way we interact with technology. The journey of microchip creation intertwines artistry and engineering with exceptional precision, culminating in the heartbeat of modern electronics.